Good morning. Feels great to see a lot of you here in this talk, where we talk about how do you extend KRM beyond Kubernetes workloads and reach to a state like KRM++. So
I'm MJ. I'm one of the maintainers at KCP. I work for Cast AI. We basically do funky things with Kubernetes.
I'm Nabarun. I do some Kubernetes maintenance, and I also contribute to KCP on the side, and you can find me on these socials. So let's get started with the talk. So we're going to see three things in this talk. In part one, we're going to see what is KRM, if you are not really familiar with it or don't know the gotchas or nitty-gritties of it, and we will come to know like why it got such success. Then we will explore how does KCP add to it and how the KCP project is pushing for the next evolution of KRM. And later on, we will try to show you a demo of how do you create custom APIs without using CRDs, but still the Kubernetes API machinery through KCP. So let's get into a problem, like why are we here and why are APIs so hard to do? So imagine you are a tech company running a hybrid cloud setup, and you want to create infra resources like compute or some networking stuff or some storage things. So you'd be interacting with a lot of different cloud providers if you are on multiple clouds. The problem that comes is consistency across providers. Every provider has their own different APIs. Interoperability between them, and then the whole ecosystem, how do you build things? When you try to integrate all of it, it surely becomes a little overwhelming, and at that point, you might ask yourself a lot of questions, what are we even doing? And often, why we do that is we really like reinventing things. We like to build our own new standards. But then should we? As a tech company who knows what their business goals are, what their business metrics are, you should ideally do what you know the best. You know your area of business, you know where is your value proposition, and you should start to stop inventing outside those areas. And you need to start seeing something which is more like a standard and used by a lot of people. So we do really have an answer that we should not try to reinvent if there are existing patterns that you can use. And there comes the Kubernetes Resource Model. You all have been using it through the Kubernetes API. It's basically the API surface of Kubernetes and how things are done. What are the key properties of those? First, declarativeness. So you don't ask the Kubernetes API to do things step by step. You don't ask it to, hey, can you start creating a pod of this and this, basically say one by one. What you essentially do is you tell it directly, hey, I want to create a pod with this image, with these resources, and here is where it should be located. It's basically the declarativeness of KRM. And when you start creating those resources using KRM, you have a structure which is pretty consistent across the whole surface, and it has been consistent across probably a decade now. So what do you see when you create a Kubernetes resource? You have an API version, you have a kind, what kind of API it is, then you have certain properties of the resource, like its name, some metadata associated, like annotations, labels. Then you have two key properties. What is the state of the resource that you want? When I explained about the pod, that's your desired state. And then you expect the system to return you back, like stamp your resource with something like a status. Now, all of this is known to us, right? It sounds very trivial now. And when you try to create any object in the Kubernetes control plane, you essentially have this specific format, no matter what you are dealing with, other than probably two outliers, config map and secrets. But maybe we can skip those when talking about this. And it just works, right? Nobody questions the structure anymore. Everyone is quite okay with it. And the next important part is when you tell the system that this is the state I desire, there are some processes running asynchronously, reading your objects, reading your resources, and then trying to reach that desired state. If it can reach that, it will stamp back with some good, successful statuses. Or if it is not able to reach that state due to some error condition or some unfulfilled states or anything, it will report back the same status back to the resource itself. So these three things make the Kubernetes resource model really powerful for your use cases. But do you think it's that easy? Like, can you just start writing some Go types, use Kubernetes code generator, and then create CRDs? Does sound easy, but then you can do really weird things with it. So there are some pitfalls, there are some gotchas that you have to know when writing KRM APIs. Some quote from Albert Einstein. So let's come to the things that you should avoid when writing KRM APIs. First, mixing the business logic into the CRD's design. So we talked about spec and status, right? Two very segregated parts of the object. Sometimes what happens is we might try to put too much logic into spec. That's not something that we should do. We should just put things which mention how the desired state of the system should look like in a spec, and not too much of procedural knowledge. And not clearly separating the spec and status. For example, here in the case of service, right, when you ask the Kubernetes API to create a service, do you really give cluster IP always? Not really. You say like what port I need to expose, and it comes and stamps cluster IP in the spec. Whereas should it have been in the status? I mean, this is all debatable, but ideally, your desired state should be like, obviously you can specify your own cluster IP, but should the field have been called like desired cluster IP, and then you have the actual cluster IP in the status. So things like this you need to think about when you design your KRM API. And then if you ignore established API conventions, you again run into pitfalls. For example, here, when you define a CRD, you tell what kind it should be named when you do kubectl get so-and-so. For example, here if you see DB connection, it should ideally have been named capital D, capital B, capital C, and then the rest of it. But if you see, it is not that clear how do I read. And then when specifying the plural, it should ideally be a plural name and not just a singular again, which creates more confusion. Pretty interesting example is if you have an API called sheep, what do you define the plural as? Should sheeps, should be flock? Again, questions. And then when I talk about creating, like writing a Go type, like Go struct, putting fields, you should really leverage the things that KRM is giving you, like OpenAPI schema validation. Then you have, when you properly tag your fields correctly, the OpenAPI schema will have enough information for your API clients to actually derive information from the object itself. Things like if you want to do some pattern validation or do some sort of simple validation, or maybe even let's take it a little bit ahead with cell expression validations. You can essentially run small expressions as part of the Kubernetes API server's admission process to validate your custom resources. So things like this really make it powerful, but you need to use those. If you don't use those, then you again run into problems. And then again, like a classic example, like if your request was actually not fulfilled, but you are returning a 200 OK with the payload being status code 400 and status being bad request. That's not how you should write your APIs. So this kind of pitfalls are again to be avoided. And then let's talk about evolution of APIs. Let's say you wrote your API once, but you keep on adding fields. There needs to be a proper upgrade strategy. There needs to be proper versioning, converting between two versions, those kind of problems you run into, right? So in the KCP project, we ran into a similar situation where we have this workspace API, but it has been around for since the inception of the project, but we have been adding new things to it. Recently, we made a small breaking change, not for consumers, but anyone who consumes the workspace API through the Go library. That started a discussion like, hey, I have the next version, V1 Alpha 2, but then is that the correct one? What are the differences between V1 Alpha 1 and V1 Alpha 2? A simple conversation started a thread of 309 replies, and I'm pretty sure by the end of the conference, we would reach 500 replies on the same thread. So it's very essential to actually discuss things when you upgrade your APIs or create new versions on how, and you need to really think how your consumers are going to consume the API. Sometimes we really don't know how to do it, but then we have to discuss with everyone, all the stakeholders. And as you saw here, things escalated really quickly. I think once the thread was created, by probably a couple of hours, there were 100 replies in there discussing how this evolution should work out and how do we actually do the conversion strategy. Then again, another pitfall is we have been talking about APIs all throughout, right? But what about the reconciliation route? So Kubernetes provides you some tools and resources to write your own reconcilers. If you wrote reconcilers let's say 6 years back, if you see some Kubernetes controllers, probably all of them are migrated now. Really old controllers, they're written in work queue and by manually creating worker processes, managing them. That pattern is now slowly evolving if you really need to use controller runtime. So here you see some good patterns, right? When you are writing your reconciliation loop, there might be a certain set of actions that you want the controller to do. Now, what you can do is you can atomically divide each of these operations into its own reconciler. Now, what it does is each of these reconcilers can be easy to write, easy to test, easy to mock, and the complete reconciler would be very easy to read by anyone. And when you aggregate statuses across it, it's very easy for you to also atomically think, okay, there was an error here. Now, what kind of error it was? Was it something which is recoverable? Was it something like a state of the system which is transient, but if I requeue it down the line, maybe 5 minutes later, I would be able to successfully process the object. So you need to think about all of this. You need to aggressively think about how do you reconcile. Do you result in a proper error state? Do you result in a transient error state? Or do you result in a good state as part of that reconcile iteration? Here are some examples what can we do in each of these cases. Now, there are a lot of other patterns that you can learn from the Kubernetes code base or a lot of other projects in the CNCF ecosystem who are doing KRM APIs. A very neat example here is how do you do the committer pattern. I would just tell you it in 30 seconds. The committer pattern essentially disallows you to change the spec and the status in the same reconcile loop. There are obviously some hacks around it, but those are not suggested to be followed. Ideally, in the same reconcile loop, you should only change one, and the controller should ideally only change the status and not the spec. That's how things should work. And there are other patterns that you can learn from controller runtime, kube builder. They all help you to write your reconcilers effectively. But how is KRM better than what you have in your company now? You have a custom solution that you wrote that works for you. But you might also think hey, Nabarun is talking about creating a 16th standard and I already have the 15th one. Why should I go to the next one? Actually, it's not the 16th standard. It's the same thing that you have been using all throughout. As consumers of like Kubernetes or other CNCF projects, you might be using one or more KRM style APIs already in your tech stack. And that's why it's nothing new that you're trying to do. It's just sticking to the general flow that everyone is using. So why not just stick with something that you are already using? So now
Cool.
MJ will take over.
So let's switch gears a bit. So now KCP and how it makes it better. So let's say you want to use KRM, you want to build your internal cloud or external cloud for your organization, and you kind of usually end up with something like this. This is usual microservice architecture which you would have in your platform or cloud. You want Kubernetes microservice calls virtual machine microservice, virtual machine calls compute microservice, that needs storage, networking, and you have this mesh of interconnectivity. Like, this is nothing new. Like, everybody who works for hypervisors knows you run this already. Everybody who runs for a bigger corporate has this. So, but this is look like this. So, okay, we still sold to KRM. Let's use Kubernetes model to implement something like this. So the flow, as I mentioned, would be like request flow and a pattern. So that looks good. It's like, we've been doing this for a decade now. But usually what you build is this. Now you have a second region. Now you want to serve your US customers, European customers, maybe some customer wants isolated environment. And at some point you reach this point where now you started with one Kubernetes cluster, many operators, everybody is reconciling everything. Kubernetes team popped up and said, like, we are too big now, let's do our own Kubernetes cluster. Now you're gonna talk cross clusters. And now you've been creating like CRs and CRDs across clusters, reconcilers. And there's many projects out there who's doing that stuff. And is it bad? No, it's like we've been doing this for a decade now, totally. The same flow would be here, like if the compute team needs a storage, most case storage cluster contains some naming pattern, how you separate tenants by namespaces, where you create your requests, like storage requests, compute requests, it's get implemented. So you get this reconciliation mesh between multiple clusters. And once things start to move, like storage team updates an API, maybe we added new field, did some breaking change, things break down. So, okay, we still want to use KRM, we still want to use Kubernetes, but like, how would you do that? So what we have here is we have many clusters problem. Like why KRM? Well, KRM itself as API standard is amazing. It's great. Everybody used this for a decade. It's vessel, its ability to fragmentate tenancy isolation and have an API management behind it. It's not. So we have an API standard. We don't have a way, maybe we do, but we don't have a way to manage it. Alternatives is vClusters. Like we say, okay, we don't want to have many clusters. Let's run pod per tenant. But that doesn't solve the problems. It reduces the costs, but you still have many clusters problems. API management is not still addressed. We have a generic control plane, which is a kiddo project under KCP, which does very similar as vClusters, but again, same challenges stays. You just save some few bucks and maybe operational costs. So what's the elephant in the room? Like, we need strong multi-tenancy for CRDs, for the APIs. We need API management, interconnectivity for those things. Like, all the API things which we don't at this point. So KCP, Kubernetes-like control planes. So if the Kubernetes cluster looks like this, where your tenants is namespaces, you have airbag rules, some magic controllers. In a KCP land, this would be like this. KCP is just yet another application running on your Kubernetes cluster. It's not a replacement to your Kubernetes clusters. It's just a flavor of Kubernetes API server, which allows you to do stronger multi-tenancy and API management. So previous picture which we had before. So how the same architecture would look like in a KCP land is every team gets its own box. where we can manage the APIs, we can do our own things, but we still operate a single control plane. So now we're kind of trying to eliminate the many clusters problem. And we did that in a KCP community, and it's like, okay, so what's next? So we added this ability to lifecycle APIs too. So we got stronger multi-tenancy, we split those box apart, we still have them in the same box application, less fragmentations. And still working, it's very much work in progress about how to support multiple versions of APIs. And how we do that, and this is very important thing, is like in a normal Kubernetes cluster, when you install a CRD, API extension server accepts it, installs it, so it's like done. And the CRs live in the same cluster. So it's a one-to-one relationship. What we did, we split this logic. We say API provider owns CRDs. Instantiations of those CRs on the consumer side. And we put a boundary in the middle. We call it API bindings and API exports. What this means now, you can have a one-to-many relationship, where Kubernetes cluster is very much one-to-one. You have a API provider, API resource schema, which represents the CRDs, and you have a consumers, which represent CRs. On top of that, tenancy, we isolate them in a virtual API servers, where now your team C can become a consumer of team DB API PostgreSQL database. And I'm rushing a bit because I want to get to the demo to want to show that in action. So some of you might have seen this already. This is the tree representation of KCP workspace tree. This means this is how you organize your virtual API servers. You would say, well, your application tower, which has application platform X managed Kubernetes. Your compute tower, which has virtual machines, networking, and things like that. So it's a logical organizational structure represented in a tree structure. And that would be basically what you built. So you have different teams interacting with a single control plane, calling to each other. You have this medium to do all these things. So, and that's not a new thing. Like, if you look this and it's like, oh, this is very much overwhelming. Like, why I should do that? Like, you doing this daily, I bet every one of you. Like, this is a free APIs from Google Cloud. It's like Clusters API, a SQL admin API for creating managed databases, and a compute to create VMs. Like, it's literally represents the picture here. So while we have this, we use it daily, we might not see it mentally, but the control pattern and how we do is out there. I bet when you create a Google managed compute engine, it talks to the compute instance to get VMs, it talks to database to get some etcd flavor stuff, and it constructs a managed service, hence how it works. So what is KCP, again, to replay it? It's a single platform to manage multiple Kubernetes resources, APIs, and tenants by shifting API surface out of Kubernetes cluster. Like, all your compute, all your controllers and everything still runs in your kube clusters. They don't go away. They just run a workload like any other workload. But what we do, we externalize the APIs. They shift a bit left or right, depends on your perspective. And this is how we enable to build platforms, basically. So now, database as a service example. So this example was done yesterday in a workshop we had about KCP. So if you want to replicate it, just go to this repository. There is a very much well-driven instruction how to do that. Mr. Robert, sitting in second row, did most of the writing, so kudos to him. So let's try it. So demo God. So I have two tenants here. So two tenants, basically two logical clusters. You will see they have a different URLs. Is it enough? Should I make it bigger?
Make it a little bigger.
Yep. Let's see how it goes. So my tenant one is a consumer of database as a service. So if I do get clusters that represent a database, I have a database cluster, which if I get out, which has very overwhelming spec, which kind of should be need cleaning. If I find a type, I can see that that's a Postgres database. I have a tenant too. If I do get clusters, it's same cluster name, same object type, and how this object type now is appeared in this cluster, it has this API binding, which we talked about. So I have an API binding to the Postgres database team. Like, I will not go into details how the providers are wired up and everything. Like, you feel free to go into this workshop or other talks and that. But how this is now represented at the provider side, like a database team owns a Kubernetes cluster. And if you notice here, like what I have is I have two different namespaces running same name databases out there.
Increase the font size a little on the other one.
So basically what, and if I do, let's say, still have a few minutes, so let's try to improvise something. APIs, consumer one, cluster. So I basically rename it. It's always interesting typing in live demos. If I create a new one, okay, secrets are present. In a consumer one, I see that that's basically being set up. And on the side, I can see that tenant namespace representing here is being instantiated. So that's very high level. But idea is that you have your compute cluster where all the database team spins up the things and everything, and you have many consumers which don't talk to each other, they interact in their own virtual environments. And in the same way, that consumer could be other team using databases to build something else. So we basically did a control plane as a service and database as a service. So KCP has quite a lot of talks already in a YouTube channel and everywhere. So we had a tutorial yesterday, which we had linked, which if you like the database as a service, you can go in there and do it yourself. You are here now. We have one more talk related to KCP, which will be very interesting. I would strongly recommend to go into that. It's about a new kid on the block, how to build multi-cluster controllers with controller runtime. So that's basically it. And platform engineering in general is reaching, I would say, quite a milestone now, because more and more people are reaching this point where we have many cluster problems. So if you like what you see, if you want to join us, come and talk to us. We have stickers. You can find us at Kubernetes/KCP Dev or Twitter X, and your feedback is very much welcome. Any final words?
That's all. Covered everything.
Cool. So we still have, I think, a few minutes for questions, if there is any.
Just to add one thing, if in case you are interested to go to the, do the demo yourself, the one easy link is you can go to docs.kcp.io/contrib. That's a website with all the demos and all the presentations that have been done for KCP in the recent past.
Cool.